Okay, hello ladies and gentlemen, this is Mr. Nkosi. We meet again. So today I want us to quickly look at a mechanical drafting question 1, the conventional representation of a screw thread. So this is the previous question paper that we are focusing on, that we are doing tonight. That was written on the 21st July 2024. So it was the morning paper. So all the X papers are morning papers. You understand? So I want us to quickly look at question 1. So it's read as follows. Let me put it like this. Okay, yes. You are a draft person in a small engineering workshop. You were asked to draw an external what? Left-hand square screw thread for manufacturing. So you are drawing an external left. So you must know if they are saying external left, you understand, external left, and the type of thread is what? It's a square. The drawing must be done according to the conventional method in order that it may be done speedily. So if they are saying conventional, we are not doing all the threads, we are not drawing all the threads from point A to B, understand? So we are not drawing all the threads. It will be 2 threads at the beginning and 2 threads at the end. You get it? So if they say conventional, so the detail given are as follows. So this is the data given. The screw thread length is 120 millimeter. The pitch is what? Is 20 millimeter. The nominal diameter is what? Is 8. So draw the thread in a vertical position of your drawing sheet. Understand? So if they don't state this, so if they just don't state it, so you must know what you are going to make them horizontal. You understand? So in this case they are stating it what it's supposed to be vertical, my brother. So I'm going to start with what? So now I've planned on my drawing sheet, is already aligned. I'm going to start with a vertical center line, T-square, and my drawing set squares in touch, you understand? So I'll start with the what? With the vertical center line like this. You know, a center line, we always draw it diagonals. You know that. So you know that we always draw a center line dark. Then now from here I'll draw a faint horizontal line. So let me position it nicely. So faint horizontal line. So I'll come and be like, they set the thread length 120, isn't it? So here's my 30 millimeter ruler. I'll record the 120 millimeter that they are talking about. There is 110, 130. I'm looking for 110 millimeter, which is that one. So from there I draw a horizontal constructional line. You get it? Then from there, what is going to happen? We are given the nominal diameter. So the nominal diameter is 8. So it's 8. So I'm going to say 80 divided by 2. I am getting what? 40. So I mark it 80. I mark it 0. You get it? Then after that, I'll project this one up just a little bit faint, and this one up just a little bit faint. So you must remember that what are we doing? We are doing a conventional we are doing a conventional what square screw thread. So the position, the set is left hand, and remember, if it's a square external, not internal, you understand, not internal, so your thread, they must land on the other side. If it was an internal left, so your thread, they were going to slant on the what, on the left. But if it's external left, whether it's square or it's V, your thread is slant on the opposite of that direction that they are talking about. You understand? So then what is going to happen now? So the set, the pitch is what is 20. So I'm going to say 0.5 times pitch, 0.5. If you have done your N2 very well, if you have done your N2 grade 11 very well, you will remember the formulas of what, of screw thread, whether it's V, internal, external, or square, internal, external. So 0.5 times pitch, in this case our pitch is 20, isn't it? So I'm getting 10. What am I going to do with this 10 millimeter? You take your drawing compass, you open it to 10 millimeter. Where's my drawing compass? So I open it to 10 millimeter. This is my 10 millimeter. Then I'll start here. I mark here. I also mark here. You understand? So I've marked from here till here is 10, from here till here is 10. You get it? From here till here is 10, from here till here is 10. Towards what? Your center. You understand? If it was internal, we're going to go away away from the center. So in this case, in this side, I'll only just have to step my drawing compass, come back and confirm. So in this case, I'll just come and place it here and mark here only. You get it? So I've marked here, this is 10, then I'll come 10, 10, 10. Remember, they said conventionally. You understand? So I must have 2 threads at the beginning and 2 threads at the end. You understand? So now at the end again, I can come and say 10 millimeter, 10 millimeter, 10 millimeter, 10 millimeter. I can stop there. You get it? Then after that, I can project this one. I can project this one, faint, going up. So even this one, faint, go up. So all the lines that we've done so far, they are drawn, and they are being drawn faint. You understand? They are drawn faint beside the vertical center line. Beside the vertical center line, it is only the one that is supposed to be drawn how dark. So now I'm going to just transpose this 10, 10, 10. So I just measured once so that I use my my t-square 10 here. This is still the same 10. So this point, they must be in the same horizontal line to each other. Same horizontal line to each other. You understand? So by so doing them like that, you are saving time in the exam. You are trying by all means to save time, other than to be like 10, 10, 10, 10 using a ruler. You understand? You come on this one 10, 10, 10, you come on this one 10, 10, 10, come on this, so it's waste of time. So it's better you just do it once, then you use your t-square. They're supposed to be in the same line. You get it? So even up here, come to say 10. You see that I'm fast. If you just recorded them once, 10, 10, 10, 10, 10. So this 10, it's a what? Remember, it's a half a pitch. It's a half a pitch. So if I can name this point 0 and point 0, point 1, point 2, point 3, point 0, 1, 2, 3. So it's up to you. You can name them up until at the end. So why am I naming them? Of course, it's not necessary if you know what you're doing. Me, I'm naming them so that whosoever is with me or will be watching this video will get a clear understanding of what was really happening there. So remember, so that we call these points, we call them by their names. Understand? Remember, they set external left, and remember it's vertical. So now I am going to join point 0 with point 1. You understand? So I start with the 0, and when you are joining, we are using a 30mm rule. I'm joining point 0 with point 1. Remember, this is 0, 0. This is 1, 1. This is 2, 2. This is 3, 3. Could be 4, 4. Up until you understand. So now I'm joining 0 with 1. Because my thread, they must land on my right hand side, vertical. So solid from here till right there, solid. You get it? I join point 1 with point 2. Point 1 with point 2. There you go, solid. You get it? So it's a full thread already now. It's a full thread already. So remember, there must be 2. So I join point 2 with point 3. So it makes your work simple if you number your work. Even in your test 1 or final exam, you can still number them. Like this, my guy, they won't penalize you. You get it? So I am already having a full thread as such that I can close here. My shadow is disturbing me. Such that I can close here, dark here, and solid dark there. You get it? So it's a full thread already. Remember, conventional, there must be what? There must be 2. So 2 with a 3. Join it. So there you go. So you can see what I can still name this one 4. You understand? So that I'll join, this is 2, 3 with the 4. So there you go, solid. You get it? Then now it will become a full thread. If I now join this one with this one, this one with that one. You get it? Then from there, let's go to the end point. To the end point. So I can still have the very same numbering. I can say 0 here and the 0 here. The numbering is up to you. You can use alphabetic, you can use small letters, you can use Roman figures, you understand, as long as your numbering is consistently. So so it's better when you number so that you'll easily see when you commit a mistake. So 0, this is a 1, this is 1, this is 2, this is 3, this is 4. 0, 1, 1, 2, 3, 4. You know, I just ended here. I didn't even know Uguti they will end at 4. You could still continue, you understand? It's one and the same thing. So now remember, this thread, they must land on your what? On your right hand side. So I'm gonna join point 1 with point 0. Remember here we started with a 0 to 1, isn't it? So at the end it should be point 1 to 0. Using your what? Your 30mm. So from point 1 solid to 0. You get it? Then from point 2 to point 1. From point 2 to point what? Point 1. Okay, let me emphasize this point. The point that we are joining, do you see that we are having the inner ones as well? So the point that we are joining the outer ones for now. The outer one. So the one that are on this line, you forget about them. The one that are on this line, you forget about them for now. So if I was saying join the 0 to 1, we were actually looking for, remember they said from here till here is your nominal diameter. You understand? So from here till here is 0.5 times pitch. So remember. So even here is 0.5 times pitch. Check your engineering drawing textbook N2. You understand? So now if I can come here, I will know what is now a full thread. This is simple, straightforward. There you go. There you go. Right, so I must have another one. So I will join 3 with the 2. Using what? Your 30mm ruler and joining the outer points. There. Then I use a 4 with the what? With the 3. Look, I didn't even know what the numbering will end at 4. You understand? So there you go, the outer one. From here till there. From here till there. So these are the threads that I'm having. So now what is going to happen now? So I am going to join. Remember I started with what? With a 0 to 1. So in this case I will start with a 1 to 0. How? Like this. That's where majority of students they get to get confused. Remember I started with a 0 to 1, isn't it? So now I'll start a 1 to 0, push it like this. Then now I go to 2 with a 1. There it goes. There it goes, 2 with a 1. So what is happening there? So I'm going to have a solid line that will start from 2 till here. That's my depth, isn't it? Like this. So now we're gonna see the importance of that point. Understand? So we started 0 to 1, but now we say 1 to 0 like this. Then you push 2 to 1. There you go. Then 3 to 2. Then check again from your depth, which is that one. Solid. Understand? So this point they must never be on the same point. You understand? Under normal circumstances, they always come like this. They don't be in the same point. Remember which points are these? Are the one that we drew them with what? With our t-square. So remember we just drew what? 3 to 2. Now remember I have a 4 here, so I'm gonna say 4 to 3, and which means I must come back and have what? 5. Remember there's 4 and then 5 this side. 5 this side. So that is going to be a 5 with a 4, which is that one. You go. You understand? Then after you've gotten this point, what is going to happen? Now you're gonna take this point to what? To your center. You take this point to your center. You see how slow I am? A center to that point. You get it? And even this other side, you take this point to your center, not to those ones, because these are threadmos. So you take this point to your center. There you go, to my center. Now on this one, you take this point to your center, dark, solid. There you go. You understand? You see what is happening now? So now you take this one to that one, not here, not here. You understand? Not here. Let me try to give it a little bit of a zoom. You understand? Yes. So dark from here till here, not there, so that your thread, it will be clean, simple, straightforward. So your depth, there you go, till here, something like this. You get it? So even up there, I'm gonna dark from here, pass here just a little bit till here, something like this. You get it? So now I can have this one from here, not there, from here till here, solid, my guy, from here till there. That's my, from here till there. You get it? So which means this part we are done. So now I'll come back to this other side. We do the same thing here. So what you've done here, you are going to do it way now, right here. How? Let's come back. How have we done it? We started with a 0 and a 0, right? And then a 1 with a 0. So which means we must do vice versa. A 1 with a 0, right? So now we're gonna do 1 with a 0. Trace it. 1 with a 0. So far it's not giving us anything. So this is 1, isn't it? So we go to 2 with a 1. Try by all means to be accurate. 2 with a 1. So they go from here till there, dark. Then go to 3 with the 2. So from here till there, solid. And then you go to 4 with the 3. And then I must come back and get a 5 as well, this side. So that is why I said to you, you can have them up until at the end. So as long as you are not going to throw full thread. So it's going to be 5 with the 4. There you go. You get it. So again, you take this point, you take that point, you take this point. You understand? So what is going to happen? So now I'm going to take this point to my center. So there you go. Take this point to your center. There you go. You get it. So now I have dark from here till here, not there. You get it? Dark from here till here. Have it. There you go. Till here. You get it? So I'll come and do the same thing this other side. I can stop here. You get it? Then from here, do the same thing this other side. So dark from here till there. Don't forget about this point. And how did you got these inner points? It was a 0.5 times your pitch. The pitch which you were given right from your what? From your data given. They said a pitch of what? Of 20 millimeter. You understand? So which means from here till here is half a pitch, but from here till here it's a full pitch. If you check your textbook, that's how they dimension. So from 0 to 1 it's 0.5 times pitch. You understand? 0 to 1 it's 0.5 times your pitch, which is what? Which is 20. So we got 10. So from 0 to 2 it's a full pitch. You get it? It's a full pitch. So now I'll come back and clean up my work just a little bit there, and this one solid from here to there, and have this one from here to right there. Vandaag I'll sleep with no pencil lift. You get it? Then now what is going to happen now? Remember the word conventionally. So they said the drawing must be done according to the conventional method. So if you have your drafting textbook, go to screw thread, you will understand when they are saying conventional, what are they actually. So which means this shaft, it was too long, you understand. So they had to do this thread. So that is why they said method, in order to what to be done speedily, you understand. So the moment we draw hidden lines like this, we simply, and they must be solid, we simply shows what these here actually there was threads. So there are threads here. So this shaft is too long, like this. Then you do the same thing even here, hidden, not center. So you must draw, there must be a difference between a center line and a hidden line. You get it? So a center line is always drawn dark, long, shorter, long, shorter, long, short. But a hidden line is always drawn dark, but short, 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 short. You get it? So like this. So this was the question, then this is the solution. This is the solution. So thank you very much guys for watching. That was Mr. Nkosi for engineering drawing and mechanical drafting, and 4 we've just done this one. And if you take a closer look of this previous question paper, we've done question 1, which we just finished now. So I can write here posted already on my YouTube, and question 2 we've done it already, comes posted. You understand? Question 3, which is sectional drawing, is posted. That is why I tick there. Question 4, detailed drawing, posted. And then question 5, assembled drawing, posted. You understand? So which means I don't expect any question pertaining this previous question paper unless it's one-on-one lesson. You understand? So thank you very much guys to tune with me. See you on the next video. Bye. Danke.